Hi, I'm Katherine Fox with the Louisiana 4-H Youth Wetlands Program.
Hi, I'm Shahana with the Louisiana 4-H Wetland Ambassadors team.
Today, we are going to be looking into ocean acidification. Before we begin, let's first look at the term acidity. Acidity is the level of acid in a substance. You can measure acidity using the pH scale. The pH scale is numbered from 0 to 14. If something has a pH of 7, which is the middle of the scale, then that substance is neutral, which means it's neither acidic nor basic. Substances with a pH less than 7 and down to 0 are acidic. Examples of acids are battery acid and lemon juice. Substances with a pH greater than 7 and up to 14 are basic. Examples of bases are baking soda and seawater. Based on this chart, what is the pH of seawater? A lower pH means a higher acidity. For example, lemon juice has a pH of 2 and coffee has a pH of 5. This means that lemon juice has a higher acidity than coffee. Now that we understand acidity and pH, let's talk about our ocean. Since the start of the Industrial Revolution, the ocean's acidity has risen by about 30%. Can you think of something that's happened over the past 200 years that would cause the acidity of our ocean to rise? Let's explore the issue. Since the Industrial Revolution began, we have been increasing the amount of fossil fuels we burn to create energy and support transportation. For example, we burn coal to create electricity and use petroleum to make fuel for vehicles, aircraft, and watercraft. As the fossil fuels are burned, they release carbon dioxide into our atmosphere. Our ocean absorbs about 30% of the carbon dioxide in the atmosphere. That means over the past 200 years and today, as we burn more and more fossil fuels, the amount of carbon dioxide in the atmosphere is going up, which means that the ocean is absorbing more and more carbon dioxide as well. The absorption of carbon dioxide leads to a series of chemical reactions that causes the acidity of the ocean to rise. Why does it matter if the ocean is becoming more acidic? Scientists are concerned about the ocean's increasing acidity and its effect on marine life. In a little bit, we are going to do an activity that looks at the scientists' concern. But first, what can we do to help? Remember, the increase in the ocean's acidity is due to the carbon dioxide released into our atmosphere when we burn fossil fuels. Therefore, we need to reduce the amount of fossil fuels we burn. Can you think of some ways we can lower the amount of energy and fuel we use at home and therefore reduce the amount of fossil fuel we need to burn?
Some easy things we can do to lower our personal energy use are turning off lights when we are no longer in the room. Unplug appliances and chargers when you are no longer using them.
Turn your thermostat up in the summer by a couple of degrees and turn it down in the winter by a couple of degrees.
Find ways to burn less fuel, such as setting up a carpool or biking and walking to places nearby.
Also, did you know that plastic is made from fossil fuels? By using less plastic, we can reduce the amount of plastic that's made. Some easy ways to do this are use a reusable water bottle instead of a disposable one, and use reusable bags when you go shopping for groceries and other items.
Now that we have looked at some ways that we can help reduce the ocean's acidification, let's do an activity. For each group of students, you will need 2 glass jars, vinegar, 2 seashells, or chalk, since seashells and chalk are made of the same substance, and ocean water. To make ocean water, you need to add 1.5 teaspoons of salt to 1 cup of tap water. During this activity, we'll be looking at how higher acidity in the ocean affects mollusks. Mollusks are a group of organisms that create hard shells for protection and as a hideout from danger. Let's begin. First, make some observations about your seashell, their size, weight, hardness, and color, and any other observations that you miss them. Write down any of your observations. Then place each shell at the bottom of the jar. Cover one shell with your seawater and the other with your vinegar. In this activity, our seashell in the salt water represents a seashell at the bottom of the ocean with regular acidity. The seashell in the vinegar represents a seashell at the bottom of the ocean with higher acidity. Continue to check on your seashells after 1 hour, 12 hours, and 24 hours. Each time you check on your shells, what do you notice? Write down any of your observations.